Hello everyone, I'm Nicole Biner and I'm in the radioglaciology group. There, I'm developing a radar system to measure the temperature of glaciers, and I wanted to create a VR environment to describe my work. In the past, I've been using 2D images like these to describe my work. These images attempt to show that I'm inverting for a 2D cross-section of the glacial temperature, but because it's so ingrained in glaciological thought that this isn't possible, my images miss the mark of conveying this information. Therefore, I wanted to use a virtual environment to more strongly convey that the inversion is a cross-section through the ice column. I also wanted to give people a little taste of what it's like being on an ice sheet. The ice sheet is beautiful, but if you thought COVID was isolating, try looking at this icy horizon for a few months. DoorDash to this location is quite expensive, so you want to do your measurements quickly and get out, hence autonomy. My experiment consists of one moving platform with a transmitter and another with a receiver. As these radars move around, they collect variable path lengths and improve the temperature inversion. If you look down, you can see the temperature inversion in progress. In VR, it is very clear that the inversion is a 2D cut through the height of the glacier. The hardest part of the project was making the shader for the ice. Unity really does not want semi-transparent objects that can receive shadows. And this is a huge problem because the rover needs to cast shadows in order to look like it's on something. I ended up having to write the shader code from scratch for the ice. The lighting model was similar to Homework 2, except that the specularity was loosely modeled after the stationary phase approximation for rough surface scattering, to get the shininess exactly how I wanted. I also added a variable transparency so that the ice is opaque in the distance and transparent under the viewer so that the inversion can be seen. The inversion is controlled by this code, which changes the width of the plane based on where the rovers have been and updates the inversion with one of the inversions from an array of materials. Every object in the environment needed a custom shader so that I could control the render queue and ensure that the rovers are on top of the ice, which is in front of everything else. I couldn't control the background, so I ended up putting the scene inside a cylinder and forcing that to be at the bottom of the render queue. The rovers are guided by waypoints, and their wheels are steered towards the next waypoint. Then torque is applied to the wheels when the rovers are moving below the maximum speed. The rover models came from NASA's website and were assembled and colored in Blender. The other objects were also made in Blender and imported to Unity in a manner that automatically updates the models if changes are made in Blender. Well, this is all I wanted to say about my project, and I hope you like it.